Hello and welcome to our lesson on polymers. So polymers are made of monomers. The word monomer means a single unit that can be attached to others. So mono means one. You can see the diagram there. There's a single monomer like a pearl. Now a polymer is the large molecule of these repeating units, these repeating monomers. So here you can see it's a bit like a pearl necklace with each of these pearls being connected together in a long chain. Now in a polymer, these bonds that are holding together are covalent, and that should tell you they're strong bonds, not easily broken. Now polymers can be natural. They can occur in nature. So the most obvious one that you probably remember from biology is the DNA. If you actually write down in your biology exam that DNA is a polymer, you will pick up a mark. But other polymers, other large units, think about your foods, your starches, your proteins, your fats. We talk about them being macromolecules and needing digestion to break them down to make them smaller. Well, that's because they're large repeating units. They're polymers. And other materials like wool or silk or cotton, also natural polymers. And polymers can be synthetic, that's man-made. And we tend to think of man-made polymers as being plastics. So P for polymer, P for plastics. So polystyrene, polythene, this is polyvinyl chloride, PVC, and nylon fibres. They're all man-made or synthetic polymers. So where do these monomers come from for the synthetic polymers? Well, a lot of them come from crude oil, and that's worth thinking about later on in the GCSE when we think about sustainability and looking after the environment. A lot of the plastics we use, the raw materials for that is crude oil, which of course is a finite resource that will run out. So how do you name a polymer? Very quickly, it's not something you need to worry too much about, but here's the monomer pentene. And if we are going to make the polymer, we simply put poly in front of it, usually in brackets, so it becomes polypentene. Here's octene, so the monomer octene, and if you want to make a polymer out of it, it becomes polyoctene. Okay, so could you predict the names of these polymers here? So I've got ethene, that becomes polyethene or polythene. Styrene becomes polystyrene, and vinyl chloride becomes polyvinyl chloride, which is PVC, vacuum window frames. Okay, so we've already spoken about polymers being made of these long kind of repeating units, these long chains, and they are connected together with strong covalent bonds. So each chain in and of itself is a strong chain and would require a lot of energy to break them. But between them, there's not a lot of attraction between them, so they can easily get tangled up and move around each other. And this makes a polymer very flexible because the chains can move independently of each other. And that could be great. If you think about a plastic bag, I want it to be flexible because when I put something in it, I want it to flex with it and make space for it. So just be aware then that the polymers are held together with strong covalent bonds, and then they've got these weak intermolecular forces between the chains, which allow these chains to slip and slide over each other, making them flexible. So what about plastics that are not flexible? Why are some of them rigid? Well, if you heat a polymer, what you're doing is you're actually adding these extra kind of structural bits to your polymers, and we call them crosslinks for obvious reasons. And these are more rigid, and they hold the chains apart from each other in a very rigid structure, and that rigid structure gives the polymer that rigidity. So if you think about a plastic box or your window frames or the guttering down the side of your house, you do not want that to be flexible because you want it to hold its shape, particularly if it gets warm. You don't want it kind of flopping around and spilling everything or your window frames falling out. So sometimes a polymer, you want it to be flexible and sometimes you want it to be rigid. And the only difference really between the two is these cross links. So crosslinks makes it rigid, no crosslinks makes it flexible. So here's a typical exam question you might get about polymers. Again, if you're not sure, there's a lot of writing there, you would book the question. So it says look at the table. So you've got a table here with some information. You've got LDPE, which it tells you here is low density polyethylene, and you've got HDPE, which is high density polyethylene. Don't really need to know what those mean to answer the question. It says LDPE is used for making plastic carrier bags. Okay, so this one here is the plastic carrier bags, and when I'm looking at it, I'm thinking, okay, it's not very dense, so it's not very heavy. It's pretty strong and it's flexible. Well, that's good for a plastic bag. And then the HDPE is used for making water pipes. And again here, I guess the rigidity is going to be important here. It's strong and it's rigid. And it says explain. So give a reason why the LDPE is used to making plastic carrier bags. So you could talk about it being flexible and strong, and why the HDPE is being used to make water pipes. Well, again, because it's strong but it's rigid. And it says use the information in a table to help you. So you would quote that information in your answer. Okay, that's it for this lesson, guys. I'll speak to you later.